Tinakoto katoa no hana aho. Ni tamaki makolo toku kanai nainai ko Eileen Li tokunua. The Tinakoto katoa. Thank you, Finn. Right, so today I'm going to talk about linkage bias in IDI, and it's slightly different from the talks we hear in the morning. This linkage bias project doesn't have a special focus on health or social science. So, and to some extent, it focuses on methods more. In all the analysis that IDI supports, we all assume that the data is linked perfectly. That's not always the case. We know there are linkage errors in the IDI, and that is because records in the IDI are linked probabilistically. That means a score, a weight, is calculated based on people's characteristics, such as your full name, your date of birth, your country of birth, etc. With records that has completely no missingness, that algorithm would work fine. But if there's something wrong with the records, for example, there's typos in the person's first name, the date of birth got swapped somehow, the linking score, the linking weight would not necessarily reflect how likely this record can reflect a true match. In that case, linkage error can occur, and they can happen as this on the top right corner, false matches or false positives. That would be, for example, my census record got linked to Tori's educational record. That is a false match because it doesn't belong to the same, my census record doesn't belong to Tori's educational records. The other form of linkage errors occur in this form of missed links or false negatives. That would be something like Barry filled out 2023 census, but somehow Barry's 2023 census records didn't get linked to the IDI central spine. I looked into both the false links and the missed links, but because of the time constraint I have today, I can only pick one of them. And so in the following slides, I'm going to talk to you about the false links, and in particular, how I'm going to identify false links in the IDI using 2013 census data. All right, so with false links, disclaimer, because what I'm going to show you are results I obtained from IDI, and these are just my research findings. They are not official statistics. We've come up with multiple ways of identifying false links, potential false links using 2013 census data due to the well-known issue of 2018 census. So we didn't use 2018 census data. And also 2023 census data was not available at the time. Yes, so with all the different approaches of identifying false links, I'm going to talk about one of them, which I call the inconsistent spine indicator, and that is based on the special feature of the IDI. We know that the IDI is made up of node datasets, like measure of education data is one of the nodes, measure of health is another one of the node datasets. And every time a linkage is done, every record gets linked to the spine. And from there, so every node dataset linked to the spine before they can link to each other. So if we want to get successful linkage, we want every person from every node dataset to link to the spine. But that's not always the case. We know there are refreshes that are coming out every 3 to 4 months to reflect the changes in the data or the addition of new datasets. Well, so what I did here is I tracked through 2013 census respondents over time. I looked at 6 refreshes in a row and see if they all get consistently linked to the spine. Because if they didn't get linked to the spine in one time and got linked to the spine the following refresh, that may reflect, oh, this person's linking weight may be just lingering around the threshold value. So this time I'm classified as a link, next time I'm not. Those are the easy links. So if I look at 6 refreshes, you see example 1 is my stable link, so they got linked all the time. Example 2 are the easy links. They got linked in refresh 2, 3, 4, 2, 3, and 5, but not the others. So these ones are the ones that I think are likely to be false links. And if I show you the distribution of those potential false links by ethnic groups, hopefully you can see from the back that from your left to right, we have European, Mali, Pacific, Asian, Mila, other, and missing. The missing category contributed the most to false links. And even though I didn't get this, have a slide for mislinks, but the results for mislinks is more or less the same. That missing category actually contributed the most to mislinks. What does that tell us is people with missing information are more likely to be linkage errors regardless of mislinks or false links. Okay, so that was just how I identified false links, potential false links. But really what I want to do is to see if I have those false links in my data set, and if I run some analysis using this data set, would those false links or mislinks, or them combined, introduce any bias into the analytical results that I want to see? And the analytical results could be a coefficient, or could be an odds ratio. In the case that I'm going to show you, this case is looking at a parameter, a coefficient. So linkage false links only become relevant when we have more than one node data set. And as I said, in the IDI, there is a central spine, there is node data set linked to the central spine. In addition to 2013 census, so this census is 2013 census. In addition to that, I also use Ministry of Education data as my second node dataset. So false link is defined as being false from either the census to spine side or from the MOH to spine side. And mislinks, we're not going to talk about them. So what I did next is, so the worst case would be all the false links had wrong outcome. And what I'm going to show is, what if all the false links had a wrong outcome variable? How my estimated coefficient would be biased due to that. And the way to do that is, in this case here, this is my dataset. And my algorithm has identified this third one, the male Asian, as a potential false link. See here, a flag of 1. Those attributes, sex, ethnicity, and income, come from 2013 census, and my percentile score comes from Ministry of Education dataset. So what I'm going to look at is, I'm interested in whether having a higher income or household income would have a positive impact on the student's educational achievement. But this person here, the third row, appear to be a false link. What am I going to do with that? I have a pool of candidates where those people here share similar characteristics as my false record here. So see, they're all male Asian. What I'm going to do is to, in this pool of candidates, randomly select an outcome to replace this person's outcome here. And therefore, in the replaced dataset, I have this was 0.11, and now I have 0.41. See on the previous slide, I have 0.41 here. So in this goal, I randomly selected 0.41 to replace 0.11. In the next run, because this is a random process, every time I make a selection, it's going to pick a different outcome value. Right. So I've done this random process 200 times to reflect the real variation. And what I've observed is, so this is the model that I run. I said I wanted to look at whether household income has a positive effect on percentile score. This percentile score is at NCEA level 1, basically tells us how well the student does across all the standards across 1 year. So the higher, the better. And the percentile score goes from 0 to 100%. Okay, so this vertical blue line here is assuming my data is perfectly linked. There's no linkage, there's no false links. This is the parameter, the beta coefficient that I got from running the regression model from on the previous slide. And now, as I described, I've run this this random selection algorithm 200 times, and every time I got a new data set, I run my regression line. And so after 200 times, I got 200 beta 1 coefficients, and if I plot them, that's the green curve. What you can see is there's no overlap between my naive estimate and my curve reflecting the potential effect of false links. That indicates there are some bias due to false links. However, if you look closer, I'm showing these here on a tiny scale that goes from 1.9% to 2%. How tiny that is. If I zoom out and show you the entire scale goes from 0 to 100, that is what you see. So essentially, there is no difference between the biased and the naive estimates. However, that was just showing you the result by looking at 2 node datasets, and with any real idea analysis, we know that it's very common to use more than 2 node datasets. It's usually you get the person's census information, and then you add on the person's income from tax, and then you add on the person's benefits from MSD, and then you add on the person's educational records from MOE, and then you add on more. So what are the cumulative effects of false links and mislinks in idea analysis is what I want to do next. But however, the funding for this project was from MB, thanks MB, but the funding has finished. So yes, but for now, that's what we have.
Did you kind of pick a period over which the methodology, because I know STAT sometimes changes methodology for doing the linkage, and like I remember a few years ago there was a change that made quite a noticeable difference.
Yes.
Was that like consistent over the period you were looking?
Yes, that's a really good question. The method that I created, looking at the linkage pattern to the spine across refreshers, is only available for the active refreshers that Stats New Zealand provides through the IDI. We know that I think it's 2 years. It only stores the most recent 2 years refreshers, and things that are older than 2 years tend to be archived. And if it's archived and their users have no access to them at all, that means I could only look at a shorter, I think 6 refreshers was about 1.5 years. So for 1.5 years. And definitely if I was able to look at the longer term, say I have 20 refreshers available, I could have adjusted my approach to account for all 20 refreshers. But that was not possible.
To the extent of the instability of a person's, like you just did, they either were stable, had some mismatch. Do you think if you took into account, like they were only missed matches in one refresh, but all the rest they were linked, Whereas you might have one person who was linked once and never again. Do you think that would make a difference?
Well, we are counted for all of the. So only if you get linked stably across all refreshes, you are a true link. Otherwise, if you didn't get linked, even at one refresh, you are still considered false links. And that may be an overestimate of the real false links, but that's what we could do without the ability to access the raw data. The raw data means the person's identifying information, the full name, the full address, the full.
Just a quick one. Would the impact be more obvious for surveys? So, minor bias. So in Census, it's not going to show up very much because it's only a couple.
Yes. I think definitely yes. I think Census. I picked Census. One of the reasons is it's the easiest to work with because Census data is of higher quality and it's even though there is low response issue, but still the coverage of Census data is quite good. The question was, would this be the same or would this be different for survey data? And the answer is, I think so, yes.